Hello and welcome to Business Reporter's The Future of Manufacturing campaign. I'm Alistair Greener. Every few years, EU authorities update the European emission standards for petrol and diesel vehicles. It's one of the EU's most effective tools to lower transport emissions. But this regulation represents a collective challenge for manufacturers, who have to juggle the protection of their profit margins while having to meet ever higher standards. In such an environment, every faulty part and every recalled component is one too many. The good news is that smart technologies can make quality control inspections vastly more accurate and cost-effective than they currently are. To discuss these technologies, we're talking to Marco Grilt, Product Manager for Inspect Vision Systems from INEA, a company that has helped manufacturers of catalytic converters and diesel particulate filters take component inspection to a whole new level. Marco, I'd like to start off, if I may, talking about emission standards, which are becoming stricter almost every year. What does that mean for car makers and their suppliers?
Well, they need innovative ways to reduce costs that are biting into their profits, while having to meet ever higher standards. In such an environment, every faulty part and every recalled component is one too many. Manufacturers need to be one step ahead, and that usually means an increase in R&D investments, where quality control plays a big part. The entire exhaust system supply chain with extruders, coaters and canners, they're continuously adjusting their production process. Extruders, for instance, they need to increase cell density, coaters are adapting wash coat, and canners are responsible for putting the compliant end product together.
What does quality control of catalytic converters look like today?
It can be time-consuming, completely subjective, destructive, and it's lacking traceability. Today, some manufacturers are still checking quality manually. This way it's quite time-consuming, and also continuous quality assurance can come under question, as it is relying solely on the person doing the inspection at that particular time. This procedure can be done at incoming quality control and outgoing quality assurance. Sometimes only every 100 product actually gets checked. You can have 2 good parts and 98 faulty parts, but the later these faults are detected, the costlier it becomes to correct. With automated processes, it's the same thing. Sometimes the checks are only superficial. To see the inside of the product, quality teams, they take samples of the parts and they use a hammer and chisel to break them in half. These tests are used for coating depth control and finalized scanning process inspections. Today's quality control is costly, slow, and it's not 100% accurate.
Is there any other way to do this?
Today's technology allows automated, continuous, and precise inspection of every single catalytic converter or DPF, also multiple times through its manufacturing process.
How can such levels of precise quality inspection be achieved without jeopardizing productivity?
Our vision solution is looking at less than 1/10 of a square millimeter surface area of each cell channel. In those tiny surfaces, we are checking for plug channels or possible optical leaks while running the handling conveyors with speeds that can reach cycle times of 2 seconds per part. Because of higher density of the cells, we are using high-resolution line scan camera with telecentric optics and also special lighting that we are then able to provide an image that shows the part how it looks, so we can see the light going through and through. With very small footprint, it's not taking valuable space on the shop floor. We can position it in the process at the beginning or the middle or the end of the line, either between existing conveyors or in robot cells, where robot is placing the products directly in the machine.
how are the results evaluated, and how does the system decide whether a part has to be rejected or not?
The system acquires a detailed image of each product that is then processed by a series of software algorithms. These processed images are compared to set recipe thresholds and are flagged as OK or not OK. A typical example would be a catalytic converter. We can have a catalytic converter with some number of plug cells if they're scattered all across the surface, but bulks of the plugs in adjacent cells are not allowed. With that setting, the machine can reject any parts that have bigger bulks than approved ones or more scattered cells in total, depending on the allowed set points for each particular region on the part.
Could you tell me a little bit more about INEA and your background in this space? For example, what's your footprint in the industry?
We've been in this space for quite some time, over 10 years. Now, globally, every third car on the road has a catalytic converter inspected by our solutions. With implementation in 14 different countries, our solutions inspect more than 10 million products per year on the biggest production sites.
We know that environmental and quality standards are expected to increase even further. So what's INEA's answer to that challenge? I mean, can you push accuracy of quality control even further?
Absolutely. We're always looking for new solutions and keeping our eyes open for new technologies. We want to avoid destructive tests and improve existing approaches used in production line applications. We're currently working on 3D and X-ray solution that scans the product inside out and provides near real-time control of the process. By executing complete surface quality like cracks, chips and gouges, and internal structure inspection such as coating profile, we're also delivering a great warning system for part of the process to be checked or adjusted. Advanced deep learning algorithms can take this type of solutions even further in terms of predictive maintenance and non-deterministic image processing.
Well, it's certainly very exciting to hear the latest quality assurance innovations for catalytic converters, as well as other ideas you have in development. Marco, thank you very much indeed.
Thank you for having me.